Hey gang, so we're on this last little bit, which is the perpendicular bisectors and Voronoi diagrams. So we're going to try and make a couple of videos, but I also have some other ones that I'm going to attach to this. All right, so we're going to start off, this is section 3.5. We're going to talk about equidistance. That means it's the same distance. So I've got a picture here, and I'm going to talk about this line right here, and M is my point. And when I talk about something, the locus of points that are equidistant from the points A and B is called the perpendicular of the line segment AB. So here's AB, and I want to say that the let me see if my pen's going to work. The perpendicular of the line segment AB, and each of these points right here, oh, sorry, I forgot the word bisector. I'm not feeling too great, which is why my voice sounds all kind of cruddy. Hopefully I'll make it to school next week. I just have like my allergies have flared up with the cold weather coming in and all the maybe we'll get some snow. Anyway, okay, they are equidistant. So the perpendicular bisector, it satisfies two conditions as it goes through here, through the segment AB. All right, it's perpendicular, meaning it makes a right angle, correct? And it passes through the midpoint. So these sides over here are equidistant. All right, so it's perpendicular and it's equidistant. So remember when you're doing perpendicular, we take the slope and we flip it and switch it. Another way to think about it is that when you multiply the two slopes together, you get -1. I just like to say that you flip it and switch it. Remember in IB world, we like to say slopes. We use the word gradients, but remember all that means is the word slope. It means the same thing. So if y equals 3 over 2x, I would say that the perpendicular slope would be -2 over 3 would be the perpendicular slope. I would flip it. I'm going to put the note over here. Flip it and switch it. Just a reminder for perpendicular slope. Okay, so find the equation of the perpendicular bisector of a line segment that has these two endpoints. So I'm going to draw a little picture here. And remember, if you're watching this, you can always fast forward it if you kind of remember all this. I'm going to draw my segment, and I've got 4, 7. If I want to find the perpendicular bisector, remember that's going to be, it's going to go through this point M right here. And I need to know what's that order, or what's the coordinates of M. And I want to know what's the equation of L. L is going to be the perpendicular bisector. So the first thing I need to know is what's that midpoint. So the first thing we're going to do is find the midpoint. You remember how to find the midpoint? We're going to take the x values, add them up. So 2 plus 4 over 2, comma, and then 3 plus 7 over 2. So the midpoint is 6 over 2, which is 3, and 10 over 2, which is 5. So 3, 5 is the midpoint. Then I also need to know what is the slope of, I'm going to call this AB. I think I should have put, oh, I guess I didn't. I'm just going to call this, I probably did call it AB and I'm just not seeing it. The slope of AB. So I'm going to do 7 minus 3 over 4 minus 2. So that's going to be 4 over 2, which is 2. Now, remember, I have to flip it and switch it. So I'm going to say that the perpendicular slope is -1 over 2. To write the equation of the line, I need a point and a slope. I've got both. I've got a point and I've got my slope. I'm just going to write the equation of the line. Y minus y1 equals the slope times x minus x1. So here we go. Y minus y equals -1/2 times x minus 3. If I simplify that, you end up getting y equals -1/2 x plus 13 over 2. All right. Oh, that did not right there. Nope. There we go. All right. So let's go to example 45. Find the equation of the points that are equidistant from the 2 points. All right. Well, if they're equidistant, oh yeah, we need to find the midpoint. All right. So here we go. So I've got A right here. I've got B right here. A is at -1, 1, and B is at 3, 3. If I'm going to find equidistance, I need to find this point here. I'm going to call it M. that is going to be the perpendicular bisector. I'm going to call that line L. All right, here we go. Let's find the midpoint. Then midpoint is going to be 3 plus negative 1 over 2 and 3 plus 1 over 2. All right, so the midpoint is going to be 2 over 2, which is 1, and 4 over 2, which is 2. So there's my midpoint. I'm writing the finding the equation. Had to look and see what I was doing. Finding the equation. So I'm going to need a slope, right? So I'm going to find the slope of AB, and the slope of AB will be 3 minus 1 over 3 minus a minus 1. So that'll be 2 over 4, so that'll be 1/2. My perpendicular slope, flip it and switch it, so it's going to be -2. So I've got a point, I've got a slope. You're going to write the equation of a line. When you do that, you're going to use this formula up here. You're going to do y minus the y value, which is 2, equals the slope times x minus 1. Simplify that, you're going to get y equals -2x plus 4. All right, I'm going to move on to example 46. All right, in a thunderstorm, you hear thunder. Oops, go here. You hear thunder after you see lightning strike. Two friends who live near a beach are watching the same thunderstorm and heard the thunder at the same time. This means you must be equidistant from where the lightning struck. If Autumn's house is 9 kilometers south and 4 kilometers east of the beach, and Bonsuri's house is 8 kilometers south and 7 kilometers west of the beach, where did the lightning strike? All right, so we got a lot of information here. I'm going to start off because when they start going north and south and east and west, I really need to have a graph so that I can figure this out. So let's go north, south, east, and west. Autumn's house is 9 kilometers south and 4 kilometers east, right? So we're going to do, let's see, Autumn's house, 9 kilometers south. So that's like, let me do this. Autumn's south is going to be -9. It's going down. And then it's 4 kilometers east. So I'm going to say that's going this direction. So it's like over 4 and down -9. And then the other guy's house is Bonsuri's. He's 8 kilometers south, so he's like -8. But he's 7 kilometers west. So I'm going to say that's like -7. So I'm doing -7, -8. Okay, so now I've kind of got that. So I'm going to use A and B. I think that'll be the easiest. So I'm going to switch over to blue. So I'm going to go 4, 1, 2, 3, 4, and -9. I'm just going to kind of throw it down here, and I'm going to label this A. And over here, I'm going to go -7. This was -9, so -7, -8 will be like a little bit higher than that, and I'll label that B. And then I'll connect those dots. So it's something like that. Probably off a little bit. Okay, so what I know is that they're equidistant from wherever this lightning struck, they're equidistant from it, right? So what I need to figure out is what's the perpendicular bisector of this line. So let's find the midpoint of this line. All right, so let's add up the x's. So 4 plus -7 over 2, and then let's do -9 plus -8 over 2. Let's add those up. We're going to get -3 over 2, and we're going to get -17 over 2. Okay. I'm going to go ahead, I think just to make it easier, I'm going to go ahead and convert this to decimal points. I think it'll be easier to work with. So I'm going to say -1.5 and -8.5. Okay, that'll be a little bit easier for me to do. And then let's also find the slope of AB. All right, so I'm going to do -8 minus a -9 over negative 7 minus 4. So that's going to be 1 over negative 11. So I need to do the perpendicular slope. I'm going to flip it and switch it, so that's going to be 11. All right, so I've got my slope and I've got this horrible point. Okay, so I need the equation of the line that goes through this point and has this slope. And then I can use my calculator to help me with this. So y equals, oh, not y equals, I jumped the gun on that, didn't I? Let's go here, y minus negative, so I'm going to make that positive, 8.5 equals 11 times x minus a negative 1.5. So I'm going to simplify this, and when I did, I've already done it on my paper, I got y equals 11x plus 16.5. Okay, so this is the equation of this line. And now it said, where did the lightning strike? So it struck somewhere on this line. I don't know where, but it just struck somewhere on this line. Somewhere on this line. Now, if I wanted to graph it, I could. I could say, now let's see, negative 1, 2, 3, negative 1.5, and then it'd be like right about here. And I could try and graph that line. Let's see, 16.5 is the y-intercept, so it's like pretty high up there. So you might think of it like this. Somewhere on that line right there is where it struck. And it could have been up high, it could have been down low, just somewhere on that line is where it struck. All right, look at number 47. Find the gradient, that means slope, of the perpendicular bisector of a line segment with the endpoints. Okay, so again, you're just finding the slope of a line with these two endpoints. So I'm just going to say the slope of AB is these endpoints. So 0 minus 2 over 0 minus a minus 1. Negative 2 over 1 is negative 2. The perpendicular slope, the slope perpendicular, let's flip it and switch it. So it would be 1/2. There's our perpendicular slope. All right. Number 48. Point M is given by 0, negative 7, and the line joining AB has an equation of that. Find the equation of the line perpendicular to AB passing through M. All right, so for this one, we need to graph this. I think I need to draw a picture. I'm very visual. So point M is given by 0, negative 7. So let's do this. M is given by 0, negative 7. And then we've got an equation of a line joining A and B has this line equation, right? So let's do this. We're going to say A and B. That line right there is this line right here, okay? So let's do this. Let's say negative x minus y plus 3 equals 0 is that right there. And then M is 0, negative 7. That's M. Okay, that's what we know. And then we'll put, I'm going to change colors on that just to give it a little bit more definition. All right, and I'll call this L. Usually for the perpendicular bisector, we usually call that L. All right, find the equation of the line perpendicular to AB. So I want to know the equation of L. All right, well, to write the equation of a line, I need two things. I need a point on the line, and I need the slope of a line. Well, for L, L is the equation I want to write. Do I have a point? I do. I have 0, 7. 0, negative 7. 0, negative 7. Do I have the slope? I don't have the slope, but I do have the slope of this line. It's inside there. So let's find the slope of this line. Even though I don't have the endpoints, I do have the slope hidden inside there. So here we go. Let's take negative x minus y plus 3 equals 0. Let's put it in slope-intercept form. So let's add x to both sides. Negative y plus 3 equals x. Let's move that 3 to the other side. Negative y equals x minus 3. Let's divide everything by negative 1. So y equals negative 1x plus 3. So that means the slope of AB is negative 1. So that would mean the perpendicular slope, flip it and switch it. It's negative 1, so it would be a positive 1. So that would mean that the slope of my line, L, is 1. Okay, I've got a point and I've got a line. Well, y minus negative 7 equals the slope times x minus the x. And you may already be going, well, isn't that the y-intercept? Yeah, it is, but I'm just going to go ahead and do it. Y plus 7 equals 1x, and that'd be 0. Y equals 1x minus 7. Question was, find the equation of the line perpendicular. There's the equation. All right. Now, I believe that brings us to the check for understanding. I believe the one you guys are doing is on a yellow piece of paper. And I will let you have it. I know this is a real short lesson. Perpendicular bisectors are easy.